Eastbound drivers at the Hampton Roads Bridge Tunnel will begin traveling over a new bridge this weekend. It's part of the HRBT expansion project. Starting tonight and into Sunday, 2 eastbound lanes will shift to the brand new South Trestle.
Tonight is celebration for a major milestone in the state's largest highway construction project. Mary, the tunnel boring machine, broke through the head wall at the South Island of the Hampton Roads Bridge Tunnel expansion.
Under the state of Virginia lies one of the largest feats of engineering in American history. And though it is generally known as an underwater tunnel designed to reduce traffic,
it's currently Europe's biggest construction site and the world's longest prefabricated road and rail tunnel. Costing more than €7 billion and mostly financed by Denmark, it is part of a wider EU plan to improve travel links to northern and southern Europe.
A closer look at recent activities shows something that goes far beyond civil construction. Something long forgotten was found, buried beneath the Chesapeake. Something so important that it turned an average engineering project into an urgent operation that shifts the balance of global trade. What was discovered there, and what are its global implications? Join us as we explore these shocking discoveries and their global impact. Engineering below the sea. Every great discovery has its humble beginnings, and to understand how it happened, we have to go back in time to 1957. The year when one project would do the impossible and redefine the entire future of global trade and transportation. And the result of that project is the Hampton Roads Bridge Tunnel. But before that happened, something interesting was going on at the time. You see, back in the 1950s, the population of southeastern Virginia was growing very fast.
Ranks Virginia as the 5th fastest growing state in the country. So that's very interesting there. The growth index compares the number of U-Haul trucks heading to Virginia versus the number of those leaving the Commonwealth.
And traffic issues at the existing ferry and bridge links were worsening. Enter the original Hampton Roads Bridge Tunnel, the project that opened its 2-lane tunnels running into the sea and out to reduce traffic. It opened in late 1957 on November 1st at a cost of about $44 million. That cost was valued at over $500 million in today's money, creating artificial islands and immersing deep tunnels under the Strip Channel. Despite how impressive the project was, it still wasn't enough to solve the traffic issue. So on November 1st in 1976, the crossing was expanded to 4 lanes at a cost of an additional $95 million, valued at over $1 billion today. 10 years passed, and the load was already reaching breaking point, carrying over 100,000 vehicles each day during the summer.
It's moving 100,000 cars a day. Imagine when we double the capacity, how many more it can move efficiently across our harbor.
The construction was too small for oversized vehicles, and the 4-lane configuration lacked redundancy. The project needed to expand once again, but there were many problems. As far as many engineers knew, there was no safe way of expanding the tunnel without it leading to a major disaster. This was because the Hampton Roads Bridge Tunnel was below the mouth of the Chesapeake Bay, which was one of the busiest and most unstable waterways on the East Coast. Above the bridge tunnel were massive container ships and naval vessels passing every day through the overhead channels, drawing over 45 feet of water. Underneath that is a soft, shifting layer of silt and clay that behaves like deadly quicksand when put under pressure. Going ahead with expansive construction like this was a recipe for major disasters, as it would destroy the delicate balance that keeps millions of tons of water from instantly destroying the bridge tunnel, and that wasn't even the troubling part. On top of that, the original tunnels were built using the immersive tube method with fragile joints that would crack when exposed to the changes that come with construction. Throughout the 80s and 90s, multiple proposals were made on how to pull this off without destroying everything, but they were all dismissed by the workers for fear of safety. These proposals didn't account for the military infrastructure, as the bridge tunnels were constructed between Naval Station Norfolk to the west and Langley Air Force Base to the north. Both stations relied on that deep water channel for moving important submarines, destroyers, and aircraft carriers. Any extended closure or miscalculated dredging would ground Navy ships and interfere with important military operations. The restrictions became so strict that the U.S. Navy demanded that any expansion should not disrupt the seabed in any way, that there was also no way to close the tunnel for a few years at this point without paralyzing the entire region, as the other routes in the area weren't enough to absorb the redirected traffic. Perhaps the biggest problems were the limitations in finance and technology. Even in the 90s and early 2000s, American engineers were still years away from mastering soft ground tunnels like Hampton Roads. The machines needed to pull this off back then were made only in Europe and Japan. Importing these machines, shipping, disassembling them, and adapting the parts to fit Virginia's geology was seen as too costly and impractical. The Commonwealth of Virginia at the time was still paying off long-term bonds from earlier projects, and the expansion they needed that wouldn't disrupt military operations and increase traffic was estimated to cost more than $3 billion in today's money. At that time, most tunnels of that scale were being constructed in Europe or Japan. Importing such technology, adapting it to Virginia's geology, and assembling it under the bay would have been prohibitively expensive and practically difficult. The only practical alternative was building an entirely new system crossing several miles away, except that meant new environmental reviews, land buying, federal permits, and another decade of burning through hundreds of millions of dollars. For these reasons, no one made a move to expand the tunnels, but everything changed when two major disasters struck. The first happened on July 1, 2009, when a water main burst in the westbound tube, flooding a lower chamber that pumped millions of gallons of untreated water before traffic was completely shut down for several hours. Multiple vehicles were stranded in the flood, and rescue efforts began immediately. Later on in 2016, a two-car collision happened inside the eastbound tube that caused a fire outbreak.
A bucket truck and tanker carrying hot tar were involved in the crash. State police charged one driver, William Maracos, with following too closely.
The thick smoke caused over 70 drivers to abandon their vehicles and walk out of the tunnel. The tunnel walls experienced medium to major damage across multiple areas, and the emergency responders who arrived transported 4 to a hospital and treated dozens for carbon monoxide. Both events made the need for expansion urgent, despite the costs and impracticalities. Multiple firms and engineers got to work immediately by 2017. The estimated cost had swelled to $3.9 billion. With a federal loan worth over $1 billion, the state of Virginia got to work immediately. In 2019, the VDOT awarded a much-needed contract led by Dragados USA and Vinci Construction Grands Projets, with Flatiron Constructors and Doden Campanon Bernard in the mix, and design partners HDR Engineering and Mott MacDonald. With all hands on deck, the engineers had one goal in mind: to create a massive tunnel boring system that could get the job done without collapsing the seabed or disrupting military operations, and the result of their work was the enormous machine known simply as Mary, the giant machine. Named after the famous mathematician and aerospace engineer at NASA, Mary's construction began in Germany back in 2021. After passing all factory acceptance tests in May of that year, Mary was shipped off to Virginia by the end of the year and assembled by July 2022 at the South Island launch pit. This massive machine stands at over 46 feet tall, spanning about 1.5 football fields at 430 feet in length. It weighs over 4,700 tons and is equal to over 10 fully loaded Boeing 757s. Mary's cutterhead diameter is 40 feet long, with her main drive power rated at almost 6,000 kilowatts, with a torque of nearly 37,000 kilonewton meters. This massive machine took over a year to assemble, 4 months to disassemble and ship overseas, and 6 months to reassemble once again in Virginia. The machine was built for the Hampton Roads Bridge Tunnel Expansion Project, and the idea was to bore twin 2-lane tunnels beneath the harbor, with each going 8,000 feet long and 50 feet deeper than the existing tunnels. Mary began to dig in April 2023 and provided the solution to multiple previous problems. She was able to bore tunnels under the busy shipping channels without disrupting the U.S. Navy, closing the existing crossing or defending the bay floor. But there was a huge problem. While Mary was easily solving all the issues she was built for, she was also creating new problems to deal with. For one, her enormous size meant that any malfunction deep beneath the water could cause major delays and bring unnecessary costs. And with so many moving parts, these problems were prone to happen at any time. Also, keep in mind that the mixture of sand, clay, and silt meant that there were higher risks of misalignment. Turning the machine around after completing one tunnel risked mechanical failure along with a whole host of technical issues. At this point, the future of the operation was looking grim, and each new problem largely reduced the likelihood of completing the first tunnel. Despite this, the tear-jerking moment came in April 2024, when Mary emerged from the North Island reviving pit after pushing under the ground for over 13 months, to the cheers of everyone involved. According to comments reported to Engineering News Record, the lead engineer described the first phase of the project as the kind of operation that builds confidence for the return trip. Hope was reignited for the future, and 2025 was looking to be a great year for the entire project. The years of study, worry, difficult contract negotiations, and hard work had paid off, and yet, despite the success, much bigger problems loomed with ambitious expectations yet to be fulfilled. The entire project was just a few numbers away from costing $4 billion when it had only managed to complete one tunnel. The machine still had to complete the second tunnel, transition to full roadway fit-out by ventilation, drainage, roadway deck, and lighting, before tying into widened segments and trestle. The full 8-lane underwater crossing with the widened approach roads was far from halfway done, all while the contract's funding most of the expenses were set to expire by late 2027. But even then, there were supply chain disruptions, unexpected changes in geology, and unexpected weather delays, including hurricanes. Despite these hurdles, to the surprise and cheer of the team, Mary successfully finished her digging phase on September 24, 2025, leaving only the roadway, ventilation, and safety systems to be constructed before the work gets completed. Today, it's reported that Mary has already faced some wear-out from the first route operation alone, even though she was built to complete at least 4 routes for the project to be a success by any metric. Or at least, that's what we all thought. You see, while the narrative says Mary was built to establish Hampton Roads Bridge Tunnel's path, a closer look shows something strange and unexpected happening at that location. As the months passed and barges loaded with sand began to leave the construction site every day, many observers noticed that the sheer amount of materials alone that were taken away from the site went far beyond anything that was publicly announced. What was supposed to be tunneling waste taken off to be disposed of safely was quickly vanishing from the shorelines without a trace. Why was that so? Multiple official reports from the Virginia Department of Transportation explained that as Mary dug forward, the machine extracted tons of mixed earth with slurry, which was piped back to the surface for treatment and disposal. The mixture was made mostly of sand silt and clay, and was to be dewatered, dried, and taken away to containment areas. But it seems multiple satellite images tell another story, showing a steady barge activity heading towards deep-water ports along the James River and the Chesapeake Bay. And the reasons behind these hidden operations are quite surprising. Virginia's sand secrets. According to contractors working at the site, the material was likely being sold and used for aggregate applications, implying the sand was used for industrial work. But for a project that is expected to displace a few million cubic yards of material, the number of departing loads shows much more than anyone was willing to admit. Other officials said it was part of a recycling partnership established to fund newer aspects of the project that weren't included in the contract but never mentioned the buyers. At the same time, geologists began to whisper about how Virginia's coastal sand wasn't the usual sand seen at most beaches and deserts. Science tells us that the sediments under the Chesapeake region, for example, are geologically distinct remnants of ancient mountain erosion mixed with marine quartz, feldspar, and trace-heavy minerals. This means the sand likely contains components like ilmenite, rutile, zircon, and monazite. These minerals can easily be refined to produce titanium, zirconium, and rare earth elements. These materials are the ingredients needed for producing batteries, semiconductors, and magnets used in electric motors. This means all the waste pulled up by Mary might not have been waste at all. So where does all the sand go? Why are the details absent from the official reports? And what makes it so important on a global level? The answers might surprise you. What might surprise you is that sand is the second most extracted natural resource after water. According to the UN Environment Program, the world uses between 40 and 50 billion tons of sand and gravel each year, and most of it goes into making concrete, glass, and asphalt. Every common skyscraper in your city, every highway not far from home, and even the screen of your smartphone. As crazy as it sounds, all of these things depend on the trade, supply, and distribution of sand. This doesn't yet account for the semiconductor chips and supercomputers that require the constant supply of pure silica from quartz sand, with each ton being worth tens of thousands of dollars. It also doesn't cover the current global shift to renewable sources of energy, with electric vehicles being more popular today than ever. This is why the global market has quietly become a quiet race between countries, and strangely enough, the main factor driving most of these economic tensions is sand. Nations like China and Singapore import it to expand their territories, while in other regions, sand mining has become so lucrative that illegal operations have sprung up high enough to cause intense conflicts and disappearances. Yet in Virginia, a state that isn't usually associated with mineral rushes, the same resource has allegedly become the center of equally secretive trade, except this time hiding behind the facade of public infrastructure. If this is true, then it means that for decades, the Hampton Roads Bridge Tunnel was likely never the end goal, but an alibi to something much richer. Geologists point out that Virginia's sand is very unique. The sediments deposited near Hampton Roads and the York-James Peninsula came from the erosion of the ancient Appalachian Mountains, and over millions of years, rivers have carried down fine-grained quartz and feldspar that mixed with coastal marine sediments. These sediments are rich in iron oxides and trace heavy metals, and in some deep layers cut through by Mary, tests have shown concentrations of monazite, a phosphate mineral that contains rare earth elements like neodymium and lanthanum. And while these names sound obscure to most people, it's surprising to know that they have been used for making wind turbines, EVs, and the most advanced missile guidance systems. In an age where clean technology is almost mainstream and national security is top priority, these resources are far from trivial. And when the area is close to at least 2 naval routes and stations, it makes a lot of sense why certain activities would be kept secret. So when the barges begin to move under the banner of disposing of soil, it's easy to suspect a mission that practically aims to recover minerals under the guise of civil engineering. And this is where it gets interesting. Connection with national demand. Procurement documents have allegedly shown that some of the subcontractors are most likely registered with no public addresses, and even journalists seeking the Freedom of Information Act were denied and told that the hidden operations were exempted by law. Many point out that this kind of lingo rhymes better with national defense supply chains than a mere transportation project for average civilians. If all this is true, the value of such sand can't be overstated, as a single ton of high-purity quartz used for semiconductor technologies can fetch over $10,000 once refined. Rare earth elements are precious enough to be sold by the gram, and if only a fraction of the soil extracted held these elements, we are talking about millions of dollars worth of byproducts. With the United States doing its best to reduce the way it depends on Chinese rare earth resources, even the lower supply of minerals from Virginia could change everything. After all, the Department of Energy has classified such materials as critical to national security and clean energy transitions. Virginia is currently sitting on such resources and could become a contender on the front lines of the global tech race. And while this seems far-fetched on the surface, it is not the first time geology and politics have overlapped. Similar discoveries have happened in once lesser-known areas in Australia and parts of Scandinavia, where digging for tunnels or dams, like in Virginia, revealed profitable deposits of strategic minerals. What makes this one stand out, however, is how confidential it is, as normally, environmental impact statements and assessments would publicly list where the material goes. One other explanation is that the secrecy comes from Mary herself, or rather, her limitations. The tunnel boring machine was designed to handle mixed ground conditions, but reports from workers have hinted that certain layers contained dense mineral clusters that wore down the cutter head faster than expected. Crews had to replace cutting tools ahead of schedule, causing delays. Those mineral-rich sections may have been so distinctive that they drew attention from outside contractors or federal agencies interested in analyzing them. So while Mary was built to solve an engineering problem, she may have accidentally brought forth something that belongs to a different world, one which opens the door to another kind of battle between the United States and China. For decades, trade wars were fought with tariffs and currencies revolving around steel, oil, and microchips. But now it seems the newest battles are about what lies beneath the earth, and suddenly the Chesapeake Bay has entered the map. While the public sees sand as construction waste, global markets see a very strategic supply, especially for the domestic military. China has long dominated the refining of rare earths, using that control to dictate prices and pressure rivals like the United States. Every electric vehicle motor, smartphone chip, and missile guidance system depends on those minerals. So when tests from the Virginia dig hinted at similar materials buried along America's coast, the conversation inside Washington shifted from infrastructure to independence. Either way, one thing remains clear. The digging and disposal operations show that the new war isn't fought with trade and soldiers, but with stockpiles, patents, and global control over vital supply chains. So, what do you think? Are the soils of Chesapeake rich enough to stop the national dependence on other countries for rare earth minerals? Or is that just an overblown perspective? Let us know in the comments down below. If you enjoyed the video, please make sure you like, share, and subscribe. Also, click on the next video shown on your screen. You will enjoy it.